Okay, so first thing that you guys need to know is the three different types of systems, right? What are they? What are the three different types of systems of equations? Independent, dependent, and consistent. Okay. Now I want you guys to be a little bit more specific with those two, because yes, those are correct, but I'm looking for more than that. Okay. For independent and dependent, they also have to be consistent, right? So consistent and independent, consistent and dependent, and inconsistent. Okay. So that's going to be that'll be like a short matching on that little section right there. All right. So then there are going to be problems where you have to solve using graphing, but I'm going to save that to the end, so because it's especially because the problems put it closer to the smartboard so y'all can see me graph it. But there is going to be a section where you're solving systems of equations, and I'm going to allow you to use any method that you feel like is necessary. You can do elimination, you can do substitution. For number 4 with the 3 variable one, you're going to have to use a little bit of both, just like we've been practicing. All right. So without any further delay, let's go ahead and go through. These. Okay. First one. 3x minus y equals 16. 4x plus 5y equals negative 23. Again, you're more than welcome to use either substitution or elimination. Either way will work as long as the work is right. I'm going to use substitution on this one. Okay. I'm going to use substitution on this one because I see this y right here has a coefficient of 1. So if I solve for y, then whatever that value is, I can substitute it here so I can solve for x. And then whatever x is, I'm going to go back and use that to solve for y. All right, so with this right here, all right, so if I take this 3x and move it over, okay, I get negative y equals negative 3x plus 16. Only thing left to do here is to divide everything out by negative 1. 1, negative 1, negative 1. So now I have y equals 3x minus 16. All right. So now that I know what y is, I'm going to use that. I'm going to substitute it in here so I can solve for x. Okay. So that's 4x plus 5y, which y is 3x minus 16, equals negative 23. So now everything's in terms of x, so I can just solve for x from here. I'm going to distribute. All right, so that's 4x plus, it's 15x. And then 5 times 16 is, I think it's 80. So minus 80 equals negative 23. Okay, I'm going to combine like terms here, 19x. And then I'm also going to take this 80, I'm going to move it here. So I'm going to add 80 on both sides, plus 80 here. Okay, so grab my calculator. Here. All right, so let's see, negative 23 plus 80, that's 57. And then lastly, I'm just going to divide both sides by 19. X is 7 divided by 19, 3. Okay. Now I know what x is. Okay, I know what x is, so I'm going to use that, substitute it in here, so I can figure out what y is. So that's 3 times 3 minus 16. That's 9 minus 16, which is negative 7. All right. So now, when it comes time to write your answer, you're going to have 2 blanks for each problem. One of them is going to be what your solution is. If you have a solution, you must write it as an ordered pair. In this case, my solution is 3 comma negative 7. If it's in 3 variables, then you have to write it as an ordered triple. X, comma, Y, comma, Z, comma. And please make sure you use parentheses. Okay? If there's an infinite number of solutions, you would write infinitely many solutions instead. If there wasn't a solution, you would write no solution. Okay? Underneath that, you have to determine what type of system this is. So here I have one solution. Which type of system has one solution? Anybody remember what type of system? Consistent and independent. Consistent and independent. And that's the solution to this problem right here. Consistent and independent. Okay? All right. All right, we good here? Okay, let's move on to the next one. 4x plus 3y equals 7. 8x plus 6y equals 0. All right, so I don't have any variables that have a coefficient of 1, so I'm just going to use elimination for this, okay? I'm going to try to eliminate this x right here. So because now I can obviously try to do the same thing with the y, but x was the first thing that I saw that I could work with, so I'm going to just do that first. So this is an 8, so 8 is a common multiple of 4 and 8, so I'm just going to change this one. I'm going to multiply this by -2 so that this can be negative and this can be positive. That'll cancel it out. So I'm going to multiply all that by -2. So -2 times that is -8x. -2 times 3 is -6y, and then equals -14. And then, of course, I have the second equation, 8x plus 6y equals 0. Combine those, watch what happens. These cancel out. These cancel out. I now have nothing on this side, so 0 equals -14 plus 0 is -14. A 0 equal to -14. No. So what's my solution here?
Inconsistent.
It's inconsistent, but what solution is it? What's the solution? No solution. That's right. Marin, it answers two parts. What's the solution and what type of system it is. So what's the solution? There is none. No solution. No solution. And what kind of system is it? Inconsistent. There you go. All right. Good so far? God bless you. All right, let's move to this side. Okay, I have x equals 7y plus, x equals 7y plus 5, and then I have 2x minus 14y equals 10. Well, I already have x equals something, so let's just use substitution. I'm just going to use substitution right off the bat. I'm going to take this x right here and substitute it in here so I can solve for y. So that's 2 times x, which is 7y plus 5, minus 14y equals 10. So I'm going to distribute. Okay. 14y plus 10 minus 14y equals 10. Combine like terms. 14 minus 14, that's 0. So these actually just cancel each other out. And I'm left with this. Is 10 equal to 10? Yes. So what kind of solution do you think I'm going to have? Infinitely many. Yes, because I can't, because there's no way that I'm going to be able to solve for a particular variable, but yet I get something that's always true. Also, if you divided all this by 2 and you move this over, you get the same equation also. Okay, so it represents the same line, meaning that they're always going to intersect because it's the same line. And so it's your answer is going to be infinitely many solutions. And because it's infinitely many solutions, what's the type of system it's going to be? Consistent and dependent. Good. Yes. Good job. Consistent and dependent. There you go. There's my solution for this right here. Okay. All right. Then we get to number 4, which is 3 variables. Okay. So this one will probably give you guys other than the word problems, this will probably give you guys the most work. Okay. So you're trying to solve it in 3 variables. I have 6x minus y plus z equals -27. 3x plus 2y minus 3z equals -2. And x minus 3y plus 2z equals -9. All right. So again, we're going to use elimination. We're going to try to get it into this triangular form where I have x, y, and z in the first equation, y and z in the second equation, and then just z in the third equation. All right. So one thing that I always like to do is to make sure that my y's are in order from, my x's are in order from least to greatest. If it looks like this, so I'm going to switch these 2 equations right here. The third one's going to stay where, the second one's going to stay where it's at, but I'm just going to switch these 2 here. So, let me see. All right, I'm done with this. I'm going to go ahead and erase it. All right, so I have x minus 3y plus 2z equals -9. 3x plus 2y minus 3z equals negative 2, and then 6x minus y plus z equals negative 27. All right. So the first thing that I'm going to want to do is I want to get rid of these x's right here. All right. So I'm going to be doing two eliminations here. One with these two equations and one with these two equations. So I'm going to start here. I want to get rid of this 3. So I'm going to multiply this by negative 3 and add them together. All right. So when I do that, my first equation is still going to remain the same. X minus 3y plus 2z equals negative 9. Okay. So off to the side, we'll do some of my side work over here. Okay. All right. So I'm going to multiply this by negative 3 first. So negative 3 times x, that's negative 3x. Negative 3 times negative 3 is plus 9y. Minus 6z equals positive 27. And then I'm going to add this equation to it. 3x plus 2y minus 3z equals negative 2. All right. So now when I add them together, these will cancel. 9y plus 2y, that's 11y. Negative 6 minus 3 is 9. And then 27 minus 2 is 25. So there's my new second row. 11y minus 9z equals 25. All right, that's first elimination done. Next, I want to eliminate the 6. So now I'm going to multiply this equation by negative 6 so that I can cancel out this 6 here. So again, distribute. Negative 6x, this is plus 18y, this is minus 12z equals positive 54. All right, and then I'm going to add this bottom row. 6x minus y plus z equals negative 27. Add all that together. X's will cancel. I have, let's see, 17y minus 11z equals, let's see, I believe that's 27. So 17y minus 11z equals 27. Okay. All right, so we're almost done. I got one more elimination to do. I want to take out this y right here. Now, here's the thing. Let's say you can't recognize a common multiple between two numbers. Well, if you can't find the least common multiple, the least you can do is find a common multiple. And the best way to find a common multiple is to multiply these two numbers together, right? So if I take 11 times 17, I get 187, all right? So here's what I'm going to do. I'm going to make one of these negative, so I'm just going to make this first one negative. So I'm going to multiply this by negative 17. I'm going to multiply this by positive 11. That way, this will be a negative 187. This will be a positive 187, and then I should have enough to cancel out those y's. Okay. So we'll start by distributing here. So negative 17 times 11. That's negative 187x. Then plus 99z, because negative times negative is a positive. And then negative, this is, oh wait, I'm sorry, I multiplied by the wrong thing, sorry. All right, so it's 17. So negative 17 times 9, that's plus 153y. There we go, much better. And then negative 17 times 25. That's negative 425. Okay. Now I'm going to take this equation and multiply it by 11. So positive 187x minus 121y, and then 27 times 11, that's 297. So equals 297. Now I'm going to go ahead and add those together. All right, so those cancel. X minus 3y plus 2z equals negative 9. 11y minus 9z equals 25. All right, So I'm going to see 153 minus 121. That's 32y. Negative 425 plus 297. That equals to negative 128. So now, I'm sorry, this should be y and z. I'm sorry. Hope I didn't confuse anybody. Z. There, much better. Okay, because remember we were trying to eliminate the y's. We've already eliminated the x's. All right, so now the next thing left to do is let's just solve for z right here. Divide both sides by 32. So divided by 32, and I get z equals negative 4. Okay, so z equals negative 4 is at the bottom. So now I have my triangular form. I already know what one of the variables is, so I'm going to use that to solve for. I'm going to use that to solve for y. So I'm going to take this, substitute it in here. So that's 11y minus 9 times negative 4 equals 25. So that's 11y. This is plus 36 equals 25. So I'm going to subtract 36 on both sides. 11y equals negative 11. Divide both sides by 11. Y is negative 1. Okay, so there's my other variable. So now I know that z is negative 4. Y is negative 1. I'm going to put those two in my first equation, and that's going to help me solve for x. All right. So I have I'll put up here x minus 3 times negative 1 plus 2 times negative 4 equals negative 9. Okay. So that's x. Negative times negative is a positive. Minus 8 equals 9. Combine like terms. Sorry, negative 9. Combine like terms. X minus 5 equals negative 9. Add 5 to both sides. X is negative 4. So there's my solution. Okay. So remember, we're going to write it as a triple. Open parentheses. Negative 4, comma, negative 1, comma, negative 4. And because it has a solution, it is consistent and independent. Okay, consistent and independent. All right. All right, we good on this? All right. Next one's going to be really quick. We're going to solve by graphing. Okay? So remember, when we solve by graphing, best thing that we want to do is we want to put our equations in slope-intercept form. Okay? So, let's start with here. X plus y equals negative 1. So, all I really need to do is just move the y over. Okay? So, not move the y, move the x over. So, I'm going to subtract x on both sides. So, y equals negative x minus 1. Okay? Here, I just got to move the x over. So I'm going to add x to both sides. That gives me y equals x plus 3. Okay? Once you have it in slope-intercept form, now you can go ahead and graph it. So remember to graph. In slope-intercept form, these are your y-intercepts. These are what you're going to use to start out with. And then you're going to use the slope of each line to find those the next points in those lines. Okay, so I'm going to write it over here so you can see it while I'm graphing them. Y equals negative x minus 1. Y equals x plus 3. All right, so shift it over to the graph here. All right, so first things first, I'm going to graph this function right here. So this is negative 1. That's my y-intercept. That's in between 0 and negative 2 right here. All right. Then I'm going to use my slope, which is negative 1. So I'm going to go down 1 and to the right 1. So 1 and over to the right 1. And I'm going 2 tick marks over because each tick mark represents 1/2. I don't know if y'all can see that, but that's what's going on here. And just for kicks, I'm going to do 1 on this side, so up 2 and to the left 1. Now I'm going to go ahead and try to make this as straight as possible. Okay, that's this one right here, done. Okay, next, x plus 3. So here's 3 up here, between 2 and 4. My slope is positive 1, so I'm going to go up 1 and to the right 1. And then also I'm going to go down and to the left. All right, so go, make this as straight as possible. And looks like there is a point where they intersect. All right, it looks like it's about right here. So that's going to be our solution. Well, before I actually write it down, let me go ahead and I'm going to go ahead and put the graphs up here so that they're easier to see. So I have negative x minus 1, and then I have x plus 3. There. See, now, there's a little bit more clear now where my solution is. You might want to use a straight edge while you're graphing these lines right here. So there's my solution right here. Negative 2, 1. So let me annotate this here. So again, my solution here is negative 2, 1. And because there's a solution here, it's consistent and independent. All right. So yeah, put your graphs in slope-intercept form and find where they intersect. That's the solution. Okay. All right. The last part of your test is going to be word problems. Okay. All right. First word problem says, the sum of 2 numbers is 7. If one number is subtracted from the other, the result is 3. Find the numbers, okay? So there we already have our 2 equations. Sum of 2 numbers, right? Let's let those numbers be x and y. So the sum of these 2 numbers is 7. If one number is subtracted from the other, the result is 3. So let's say I subtract the second number from the first number. So x minus y is 3. Okay? Find the 2 numbers. Well, again, you can either use substitution or use elimination. I'm going to use elimination for the simple reason that I have a positive y and a negative y. So I'm just going to go ahead and take out those y's here. So I'm going to take this out. 2x equals 7 plus 3 is 10. Divide by 2. X is 5. Okay? So choose any equation that you want. Choose any equation that you want to substitute that 5 in. I'm going to use the first one. 5 plus y equals 7. Subtract 5 on both sides. Y equals 2. So first number is 5. Second number is 2. There'll be a place for you to write that down. And if you want to check it, 5 plus 2 is 7. 5 minus 2 is 3. It's all good. It's all kosher. Okay. All right. Then we go to the last one. A rectangular lot whose perimeter is 320 feet is fenced along 3 of its sides. An inexpensive fencing along the lot's length costs $30 per foot. An inexpensive fencing along the 2 side widths costs only $5 per foot. If the total cost of the fencing along the 3 sides is $3,400, what are the dimensions of the lot? Okay, so again, we have to remember, this is where we got confused the first time we went through a problem like this. The entire rectangular lot has a perimeter of 320. We're not talking about the perimeter of the fencing, just the perimeter of that lot. Okay, so if you recall, perimeter of a rectangle is 2 times the length plus 2 times the width. And so that perimeter is 320 feet. Okay, so now we have an expensive fencing along the lot's length that costs $30 per foot. Okay, so the length of the fencing times 30 is the cost of the fencing for the length, right? So that can be represented by 30 times the length. But when we talk about the width, the inexpensive fencing along the 2 side widths costs only $5 per foot. Right? So if I draw this rectangular lot, I'm going to draw it right here. If I draw this rectangular lot and I put the fencing right here, okay, the cost of this is 30 times L. The cost of each of these side widths is 5W. So that's 5W over here, 5W over here. because it's fencing along both side widths. And that's $5 per foot. So that's 5 and 5, that's 10. So if I add those up together, 30 times the length plus 10 times the width, that's equal to 3,400. So there's my two equations to find out what the length and the width are. Okay? Now, what I would recommend doing is to try to reduce these equations as much as possible before you start working them. That way, you have a much easier time. To try to figure out, to try to use elimination or substitution or what have you. Okay, so I'm going to divide this by 2. Okay, so that's length plus the width. That's 32. That's 180. And I'm going to divide this by 10. So that's 3 length plus 1 W equals 340. That way, looks like a much easier system to solve than the first one, okay? And again, it's up to you to decide if you want to use substitution or elimination. It really is. I mean, for being honest, substitution will work really well here. I could easily just move one of these variables over, and that would help me solve for the other one. I'm going to go ahead and solve for W here. So I'm going to take the length, I'm going to move that over, okay? So that's W equals negative L plus 180, okay? So I'm going to take that and substitute it in here for the W here. So that's 3L minus L plus 180 equals 340. All right, so now I'm going to go ahead and combine like terms. 2L plus 180 equals 340. Now I'm going to solve for L. Subtract 180 on both sides. 2L equals, I believe this is 160. Yeah. Divide both sides by 2. L equals 80. So just like in the math, I'm gonna have a problem set up the same way that Math Excel sets it up. It's going to be the length of the longest side and the length of the shortest side. Okay. So, but I mean, technically, this would be the longest side right here. So now that I know what L is, I'm going to use that to find W. So that's 80 plus W equals 180. So I'm going to subtract 80 on both sides. W is 100. So the length of the longest side is 100. The length of the shorter side is 80. Okay. And sure, you can go ahead and check it if you want. This is 200. This is 200. Let's see. Make sure. Oh, nope. Yep, I know what I did wrong. I divided wrong. This should be 160, not 120. Okay, so that's going to change this. 60. Yep. So make sure you guys are checking your work by substituting your answers back in here, see if it works. 160 here. Because 320 divided by 2 is 160, not 180. So 160, 60. All right, so now, again, start over. Subtract 160 on both sides. 2L equals 180. Divide both sides by 2. L is 90. Okay. Now let's go back here. 90 plus W is 160. Subtract 90 on both sides. My width is 70. So 2 times. So this is the longer side. This is the shorter side. Okay. Let's check it. This is 140. This is 180. 140 plus 180 is 320. Okay, so 30 times this is 2100. 90 times this is, oh wait, no, wrong one. I'm doing the wrong one. 90 times 30, that's 2700. And then 10 times the width is 700. That's 3400. So it does check out. So the length of my longer side is 90. The length of my shorter side is 70.